Measuring angles and arcs, explained by Justin D'Souza. The learning objectives of this lesson are to find measures of angles and arcs using the properties of circles, and to find arc lengths and convert between degrees and radians. The keywords in this lesson are central angle of a circle, degree, arc, minor arc, major arc, semicircle, congruent arcs, adjacent arcs, arc length, and radian. We'll come across all these keywords as we go on in this lesson. Measuring angles and arcs. You can see this figure. There is two radii and both of them are joining at the center B. A central angle of a circle is basically whenever two radii touch the center. Now these two radii form this angle, that is, and this is the arc. Here, now for example, ABC is a central angle because its vertices of these two radii are at B. That's the thing. And then there's, if you have, say for example, few of the angles. Now look at this figure here. 1, 3, 2. Now, how do you measure? Is if you know any of these two angles, then you know the total angle of a circle is 360. So all you can do is 360 minus the known angles, you will give you the unknown angle. Now about arcs, different type of arcs. What is an arc exactly? It is basically any part of the circle with two endpoints. Now you can see this is an arc over here. Now there is a difference between minor and major arc. You can see here, minor arc is always less than 180 degrees, whereas major arc will be more than 180 degrees. That's the simple definition. Now you can see over here P and R, the arc P and R is minor arc, whereas the arc RSP or PSR is a major arc. Now there is one more thing to know, because these are all at central angles. Whatever is the angle over here is basically the angle of the arc as well. Now over here, if it's a semicircle, the semicircle, it's a diameter. Now what's the angle over here? It's a straight line, it's 180 degrees. So this arc is of 180 degree. It's like cutting a circle into half. 360 into half is 180 degrees. And about congruent arcs, it's basically two arcs having the same arc length. Now let's look into a couple of theorems. Now here we have a circle and you can see there are some angles mentioned. Say for example, this angle 1, this angle 2. Now if these two are equal, then this arc and this arc must be equal if these two angles, or if these arcs are equal, then these two angles are equal. It's very self-explanatory. There's nothing much in this. And another theorem, it's about adding the arc lengths. Now, not arc lengths, I'm sorry, I mentioned arc, measure of the angle of arcs, okay? Here you can see this and this. If you want to find, I'll say for this one, if you find the arc length measure of RQZ, then all you need to do is add these two individual ones which is in between. Then you will get the total arc. If they're in continuous, see now head J, JK are continuous. So add these two and you'll get H to K. And this is also very easy and straightforward. Now we will apply this and solve some problems. Here we need to find the value of X, this value, given all the other things. Now this is pretty easy if you understand. This symbol is 90 degrees, right angle. Now then you can just use your calculator and solve. It is basically 360 degrees minus 90 minus 85 minus 40. So it'll be basically 180 minus 35. It'll be 145 as the answer. So this is the answer. You can just use your calculator and solve. There's nothing much in this. So 145 degrees. And here again we have another similar problem. It's basically sum these two, 165 and 145. It's 16 plus 14, 30, 310 degrees here. But this X, to find the minor arc, this 360 minus these two angles, that will be 360 minus 310. It will be 50 degrees. That's it. Over here, it's important to write the degree symbol, which I missed. This is degrees. Okay. Units are very important. And now over here we have been told PM is the diameter, okay, of the circle R. Identify each arc as major arc, minor arc, or semicircle. So now they have asked this particular arc MQ. What is this arc? This is a minor arc. It's less than 180, right? If it was say MNP, this is a semicircle, but MPQ would be the major arc. Now, one more thing. How do we tell the arcs? If I have written M and Q, you must see first is M. Next one is N. So this is the way to go. M, N, and then where is Q? Over here. Now, if it was told as MQN, then it would be this way. MQ and N we reach over here. So this is how we measure the arcs. Now, we have to find just MQ. Now, don't go all the way like this to MQ. No, the shortest distance must be used. This is MQ, only this much. So this is a minor arc. And then we know that PM is the diameter. So this total is 180 degrees, or this is 90. So this is also 90. And 115. So it's just 360 minus 180 minus 115. 360 minus 180 is 180 itself. So it's just 180 minus 115, that will be 65 degrees. So that is the answer for arc MQ, 65 degrees. Okay, there's one more question over here, that is M and P. Let's see where is M and P. So let me just use this. M and P, it's a semicircle, so this is basically 180 degrees. You don't need to do anything. It's just a semicircle, or it's 90 over here. So obviously the next one must be 90. It's a straight line, and therefore it will be 180. And M and Q, what is M, N, and Q? This will be 360. Okay, now there are various ways to solve this. Generally, they say when you're solving a major arc, this is M and Q, major arc, right? You should do 360 minus the minor arc MQ. This is one way. So 360 minus, we found this MQ as 65, that's the way. Or you can just add 180 and 115. So any way, whichever you're comfortable, that would be the answer. Over here it is 295 degrees. You can put in the calculator and solve. Now this is basically a formula which can be used. M and Q is equal to 360 minus the minor arc MQ. So the next check problem, you can try this by yourself. This is all straightforward problems. Now here there are three questions. That's GH. When you look at GH, you will understand this is a minor arc. GLH will be a major arc. Now the measure of GH is already given as 122. That's it. What about GLH? GLH. It will be 360 minus 122. So that's it. It will be 24 minus 2. It will be 238 degrees. Now the last one is GLJ. That's a semicircle. So it will be 180 degrees. That's it. Just looking at the figure, you can see this is the diameter, right? And over here it's mentioned, but looking over here also you can understand. But it will be mentioned in the question as well. So those are the answers. I hope this is clear. Oh, by the way, the major arc is GH. GLH is minor arc is GH. GLH is major arc, and the semicircle is GLJ whenever it's 180 degree. Now we have a real world problem. The circle graph shows how teenagers spend their time online. Find the measure of DE. That's it. That's the question. This is the figure over here. So basically they have told 44% spend in social media, 20% in video games, music, search engines, games, and others. So we need DE, which is the search engines, which is 12%. But I don't know how much degrees. How would I find this? Now let's think it practically. The entire circle is 360 degrees, right? Over here, each percentages are given. That means totally it's 100%. So now if I just the entire circle, I just multiply 360 by 100%, it'll be 360 degrees. Now if I just want a part of it, say I want 180, half of it, then what I need to do is, how do I find this 180 is, you have to just multiply the total 360 degrees into 50%, half of it, right? 50% means half. Then I would get 180. This is the answer. You can put in the calculator 180 degrees. This is how we get it, half means 50%. Same way, You just multiply this with the total, not with this directly, with the total, you multiply the percentages, you will be getting whatever you need, whatever the angle you need. So here, what you can do is basically 12% is required, that is DE, multiplied by 360 degrees. And now, if you just solve this up, you will get whatever is required. That's it. So you can use your calculators over here. Let's take out our calculators. 12%, you can use the symbol 12%, or you can write 0.12 multiplied by 360 degrees. That's the answer. That is 43.2. And by the way, it is a 43.2 degrees, and it's a minor arc. This is important to mention. It's a minor arc. There is, if it was say social media and videos, A, B, C, then it would have been a major arc. There is a check problem here. Please do try solving it by yourselves. This is just like the previous one, just the figure is a bit changed. All you need to do is find CD, arc CD. Where is CD? It's over here, the basketball. This is basically male participation in sport. This is a graph showing all the percentage of sports that have been participated by students, boys. Here, 17%. We don't know the angle. How much is this arc? How do we find it? 17% multiplied by 360. That's the total circle. That's it. You will get the answer. We will have to use our calculators. All you need to do is 17%. You can use the symbol or 0.17 multiplied by 360. And here the answer is 61.2 degrees. Another problem here, we have to just use the arc addition to find measures of arc. We need to find WY, this arc. Now here it's clearly visible. This is 90 degrees, this is 62 degrees. How do we find WY? Now don't go from this side because you will have to pass by Z. So that's wrong. You need to go this and this, WY. That's the arc. Now we can see W to X, the arc W to X plus arc XY is equal to measure of arc WY. So all you need to do is add 90 plus 62, that is equal to, these are all in degrees, 90 plus 62 would be 152 degrees. That's the answer. Simple addition, nothing else. That's the answer. Now again another similar one. Try it by yourself by pausing the video now. Measure of AD, this is the arc over here. Now it's very close, like the same answer. It'll be 90 plus 63, that is 153. Just 1 degree more than the previous one. Here you need to remember one thing. It's always the shortest distance to this point. Don't go to the longer one. Now if you have a way to go from AED, this is shorter, so take that one. Now even the previous case, WY, you can go from the left side, right side as well, right? WZY, but this is longer route. Take the shortest distance. That is how we do it. Nearest one, okay? And now we will go through arc length and radian measures. This is another important concept. Now let me just quickly tell you about how exactly you find radians. Why radians are used is because degrees cannot be converted to length. Now if I tell you, say for example 180 degrees, it's just a unit of measure like this. It's a flat line, 180 degree, that's it. Now what if I want in terms of length? Radian is a unit of angle measure itself, but just that this radian can be converted to lengths. Now here you can see this is the angle theta. Now imagine the radius r is any radius, like you can do a unit of any radius. Now this is also a radius, right? Now imagine you put this length as r itself, the same length, whatever the radius. If it's 1, this is also 1, and then you join this back over here to the center. So you get r, r and r everywhere, all the three sides. Whatever this is there, that is 1 unit radian. 1 radians. That unit is 1 radians. Now in terms of degree, that corresponds to 54.296 degrees. This would be 57.296 degrees. Now why this is useful is, now we are getting in terms of a length. See, we have measured this arc as a length, not as an angle. Now again, Take one more thing like this. One more same radius. You'll get over here. One more. You'll get over here. Then if you take this much, it will be about 0.1415. That is, if you have taken radius 1, 1, it will be 3.1415 and keeps on going. That is pi basically. Pi radians. Pi radians, so half of the circle, right, is 180 degrees, or the entire circle will be 2 pi radians. That is 360 degrees. This is the thing. 2 pi in the sense 6.14. This is the concept behind it. Now, if you just take it over here to the other side, it will be 360 by 2 into 3.14 pi. You can just put in calculator. You will get 57.296 degrees. So this is the concept. Radians are mainly used so that we can apply these measurements in practical problems. Say, for example, distance traveled or any other thing where anything circular movements are involved and you want to find the length or the distance covered, you can use the concept of radians to find the lengths. The other thing over here is about this angle theta. Now you can see this. Theta is given by the ratio of the length divided by the radius. In general, we use another way to find the arc length. The same form can be rearranged. L, take this r to the other side. Length will be equal to r and theta. So these are the two formulas. Now, why these formulas are useful? Obviously, you will find the arc length over here, right? Arc length is given by this angle multiplied by the radius of the circle, because all these are central angles. But here there is a condition. This theta can only be in radians. But if you directly divide this length and this radius, you will get whatever the angle in radians itself. And now even the same formula can be used to find this arc length, but please make sure this theta is in radians. Now you might be thinking how to convert to radians. It's very simple. Any degree, say you have 60 degrees, okay, this is the conversion factors. You need to convert to radian, just multiplied by pi by 180. If it's a degree measure, first will be pi divided by the angle 180. Whereas, now let me just first solve this. It'll be 1 time, 3 times, it's pi by 3. Now same thing let me do over here. To convert the radians to degrees, how would you do it? Pi by 3 multiplied by the conversion factor. Here it's radians, so first will be degree divided by the radian pi. This is a degree measure, radian measure. So if it's radians given to us to convert to degrees, you need to write degrees first, then radians divided by, and the other way around for the degree to radians. Now here the pi and pi cancels, and what happens is 180 by 3, that is 18 6 times, 60 degrees. This obviously must be 60 because we took 60 and converted it. Now see anything. Now if you have degree 90, all you do is, it's degrees, so first write radian divided by 180. This cancels, 9 1 time, 2 times half pi, or you can write pi by 2. So this is the thing. We will solve some problems on these now. You might have noticed this is example 6. We have not yet done example 5. We'll do it at the end of this lesson because the concept of pi to radian, radian to pi is very crucial for that particular example. Now here write 135 degrees in radian as a multiple of pi. This is another thing. Let us start solving this first. Here 135 is given. So to convert to radian, it will be pi by 180. So you just have to put this in the calculator. Let's use our calculators now. All you need to do is type it out as it is. 135 divided by 180, and over here it's multiplied by pi, that is shift and the symbol. You will get in terms of pi itself in your calculators, but if you press this, say 2.35, this is in terms of radians. Now if you draw a circle, we know this is the diameter. Imagine this much is pi radians. Pi is how much? 3.14. 2.35 maybe, see 3.14 is over here, 1.7 is somewhere over here, so it will be somewhere like this, right? 2.35 approximately. Or you can see there is 3/4 pi. 3/4 means 75% of the top circle, top half circle. 3/4. 0.75 times pi would be this answer. But now in this case over here, this question, they have clearly mentioned we have to write in terms of pi. So this is your answer. That's a 3/4 pi. So you can see that is the answer, 3/4 pi. Now, what about same thing question again, 240. That's the same thing. All you need to do is just change this to 240. It's 4/3 pi, 4 by 3 pi. Okay. Now, what if you have radian to convert to degree? The formula was very simple. You just first write the radian measure, 11 pi by 6 multiplied by. Since it's radians given, we have to write degrees first divided by radian. This pi cancels. You're remaining with 11 times 180 by 6. 6 1 times 3 times. It'll be 11 times 30. It is 300 plus 30. That's 330. So that will be your answer. Or you can just use your calculator. 11 by 6. Now I'll show you another shortcut. Now this is pi multiplied by 180 divided by pi. That will be this answer, 330 itself. Now whenever you're converting from radian to degree, you can easily convert another way. 11 by 6 is the numbers, right? Whatever you have pi, it's in the numerator. So what you can do is, we know pi is basically 180 degrees. Just put that. This is your answer. Now, basically what happens if you use the conversion factor? Pi and pi cancels, right? So it's gone anyways. Now this is 330. Next one over here. Instead of writing everything, just write 2 multiplied by, instead of pi, 180 divided by 3. Instead of this conversion factor and everything, directly you can do it. It's 120 degrees. That's the answer. Now here we have to find the arc length. I hope you remember the formula we had just seen a while ago. R is equal to, arc length. Now L is equal to R theta. Okay, if it was theta, it was L by R. Now we need arc length L. So they have told this arc Z and Y. How do we do this? Is just by this formula, and make sure the angle is in radian. This is in radian. In terms of pi means it's in radian. So length will be R is 9 centimeters into 3 pi by 4. So here all you do is put in the calculator. It is 9 times 3/4 pi, 3 pi by 4. It is 27 by 4 pi. But now this is length, arc length we are finding, length of the arc. So we don't write in terms of pi, we need in terms of unit. That is, nearest 100, 21.21 would be the answer. 21.21. You can see over here. That is the arc length. Now don't forget the units, it's in centimeters. So it is 21.21 centimeters long. Please do try this problem by yourselves. This is again the same one. The formula is R into theta, that is the arc length. Now we have 2 inches of radius and theta is given as 7 by 12 pi. So all you do is just multiply these two. It will be 7 by 6 pi. All you need to do is put 7/6 multiplied by pi. That will be 3.67, because nearest 100, 6 pi becomes 67. So that should be answer. That's 3.67. That's it. Now, generally, arc length will never be asked in terms of pi. So make sure you use it in calculator and solve it to the nearest decimal, whichever they ask. Now we go to arc length and radian measure, which we had skipped initially. Now this is a formula which I'll explain to you right now. You might have remembered circumference. Circumference is basically the outer portion of the circle that is given by 2 pi r. What is the total angle of a circle? It's 360 degrees, isn't it? Now imagine a part of an angle, like a certain, see, the total is 360. Now I'm just considering this particular angle, say x. And total arc length is 2 pi r, but I just want a length of this arc, L. These both can be equated, and this is a formula. So if you take this 2 pi to the other side, it will be L equals x by 360 degrees multiplied by 2 pi r. So this is one more formula to find arc length. But the formula which we had just studied a while ago is much easier. Now, if you look carefully, you will realize something. The conversion factor to radian is pi by 180. Here we have 2 pi by 360, which basically dissolves to pi by 180 itself. If you remove all this, then over here this x will be converted to radians. So this is in terms of radian, and this is sorry, yeah, this is radian, and this is r radius into theta. It's the same thing, r theta, L is equal to r theta, the same formula. It's just that there is a conversion factor of angle to radian in this formula. So you might find this formula big and sometimes confusing. So the easier way is just convert to radians and solve the problem. We will do it now. Here is a problem. Now you need to find the arc AB. This is the arc AB. So here you have 80 degrees, which you don't want in degrees. Convert to radians. It will be pi by 180. So it dissolves to 4 by 9 pi. 4 ninths of pi. Now this is theta value in radians. This is in radians. 4 by 9. Now you know what? The radius over here given, diameter is given, radius is 7. So r equals 7. So we know that arc length is given by r theta, 7 times 4 by 9 pi. And then you can just put this in calculator and you will get the answer. All you need to do is, I'm writing 4/9 foot. It's fine, whichever you write it, multiplied by 7 and multiplied by pi. That is 28 by 9 pi. That's 9.77, nearest 100. 9.77 would be the answer. Now this is in terms of meter, because 14 meters, this is the unit which will sustain throughout the problem. So if we have another problem for you to do it by yourself, do check the answer in a while. Please pause the video, try it. Now we will solve this problem. Here you can use that r theta by converting this to radian and then solving it. Or we can use the main formula as well, the big one, that is 2 pi r, that is 2 pi radius, r is 3, multiplied by x, that is x is the angle over here, 45, divided by not 180, it's 360 over here, the formula, initial arc length formula. That must be the answer. It's 3/4 pi or 2.35. Sorry, 36, because nearest 100. Or just convert this to radian, 45 degree into radians, and then multiply it with 3. That would be your answer as well. So this is how we can easily solve it up. That's the end of this lesson. I hope you have found it helpful. Please do subscribe to my channel. That would mean so much to me. If you have not yet subscribed, please hit the subscribe button. And please do share it among your friends, whoever might find it useful. If you have found this helpful, please do like my videos, and that would mean so much to me. All the best and happy learning. Stay tuned for the next video.